This video is divided into 9 sections. Take notes as you watch and listen, then take the quiz at the end of each section. The Sun, at the centre of our solar system, is a giant star predominantly composed of hydrogen and helium. Through a process known as nuclear fusion, where hydrogen atoms merge to form helium, it generates enormous amounts of light and heat. Gravity is a fundamental force of nature that attracts two bodies towards each other. In the context of our solar system, the Sun's gravity, due to its massive size, exerts a powerful pull on all surrounding bodies. This gravitational force is what keeps planets, moons, asteroids, and comets in their orbits around the Sun. Each of these bodies, including the Earth, is attracted to the Sun, but their momentum prevents them from being pulled directly into it. Instead, they move in orbits, maintaining a delicate balance between the Sun's gravitational pull and their own forward motion. In this video, we're going to take a detailed look at the largest bodies in our solar system, the 8 planets. To be classified as a planet, a celestial body must meet specific criteria. Firstly, it must orbit the Sun. It must be a substantial size that allows its gravity to shape it into a spherical, ball-like form. And lastly, it must have cleared away other objects in its path as it orbits the Sun. This is what makes planets different from smaller space objects like asteroids and moons. Okay, here's the first quiz. Okay, let's take a closer look at the planets in our solar system. Mercury. Mercury, the closest planet to the Sun, is a world of extremes and contrasts. Despite its proximity to the Sun, Mercury has no atmosphere to retain heat, resulting in dramatic temperature fluctuations from blistering heat to icy cold. It is the smallest planet in the solar system, with a diameter of about 4,880 kilometers, 3,032 miles. Mercury has no rings or moons. The planet's surface, heavily cratered and resembling Earth's moon, tells a story of a long history of impacts. Mercury completes one orbit around the Sun in just 88 Earth days, making its year shorter than its day, which lasts about 59 Earth days. Exploration of Mercury has provided fascinating insights into its composition and geology. The planet has a surprisingly large iron core, which accounts for about 60% of its total mass. The surface is marked by vast smooth plains and long cliff-like structures that formed as the planet's interior cooled and contracted. The Messenger spacecraft, which orbited Mercury between 2011 and 2015, revolutionized our understanding of this small, mysterious world. revealing evidence of water ice in permanently shadowed craters at its poles, a surprising discovery for a planet so close to the Sun. Okay, the Mercury quiz. Ready? Next up, Venus. Venus, often referred to as Earth's sister planet due to its similar size and proximity, presents a stark contrast in environmental conditions. Shrouded in a thick, toxic atmosphere primarily composed of carbon dioxide with clouds of sulfuric acid, Venus experiences the most extreme greenhouse effect in our solar system. This results in surface temperatures hot enough to melt lead, averaging around 462 degrees Celsius, 864 degrees Fahrenheit. In terms of its internal structure, Venus is similar to Earth, composed primarily of a central iron core, a rocky mantle, and a silicate crust. Unlike Mercury, Venus has a slow rotation, taking about 243 Earth days to complete one spin on its axis, which is longer than its year of about 225 Earth days. Venus's surface is dominated by vast volcanic plains, featuring numerous volcanoes, some of which are believed to be still active. Like Mercury, Venus has no moons or rings. Space missions like NASA's Magellan spacecraft, which mapped the planet's surface using radar, revealed a landscape marked by large highland areas, extensive lava flows, and large volcanoes. Despite its hostile environment, Venus has been a focal point for scientific study, helping us understand more about atmospheric science, geology, and the evolution of Earth-like planets. In terms of distance from the Sun, the next planet is Earth, our home. But let's save Earth for later, as there's a unique reason for its significance in the solar system that we'll uncover after exploring the other planets. The fourth planet from the Sun, Mars, known as the Red Planet, captivates with its stark red appearance, a result of iron oxide or rust on its surface. Mars is a cold desert world with a thin atmosphere composed mainly of carbon dioxide, and its surface conditions include huge volcanoes, deep canyons, and craters reminiscent of Earth's moon. The largest volcano and the highest known mountain in the solar system, Olympus Mons, resides on Mars, along with the vast canyon system Valles Marineris. These geographical features hint at a more active past. Mars is roughly half the size of Earth, with a diameter of about 6,779 kilometers, 4,212 miles, and it has two small moons, Phobos and Deimos, thought to be captured asteroids that originated in the asteroid belt between Mars and Jupiter. Instead of continuing in their original orbit in the asteroid belt, they were drawn into Mars's gravitational field. Mars has a composition similar to Earth, with a rocky surface made of basalt and iron-rich minerals. Beneath the surface, Mars has a solid core made of iron and nickel. Mars has a relatively quick rotation, taking about 24.6 hours to complete one spin on its axis, which is very similar to an Earth day. This results in Mars having a day and night cycle that closely resembles that of Earth. Mars orbits the Sun at a greater distance than Earth, leading to a longer Martian year. Specifically, it takes Mars about 687 Earth days to complete a full orbit around the Sun. Mars has been a focal point for space exploration, with numerous missions seeking to unravel its mysteries. Evidence gathered by these missions suggests that Mars once had liquid water on its surface, raising the possibility that it might have supported life in the past. Features such as river valleys and lake beds indicate a wetter history, contrasting sharply with its current arid state. The thin Martian atmosphere contributes to harsh surface conditions, including extreme cold, with average temperatures around -62 degrees Celsius, -80 degrees Fahrenheit, and massive dust storms that can engulf the entire planet. The exploration of Mars, including rover missions like Curiosity and Perseverance, continues to provide valuable insights into the planet's geology, atmosphere, and potential for past microbial life, making it a primary target in the search for extraterrestrial life within our solar system. Mercury, Venus, Earth, and Mars make up the inner planets of our solar system, often referred to as the terrestrial planets. These planets share similarities in terms of their rocky composition, with solid surfaces made of materials like basalt and iron-rich minerals. Additionally, they are relatively smaller in size compared to the other planets. Next, we move to the outer planets, which are vastly different in terms of size, composition, number of moons, and longer orbits due to their greater distances from the Sun. Jupiter, the largest planet in our solar system, is a true giant. It dwarfs all other planets with its immense size and mass. Composed mainly of hydrogen and helium, Jupiter is often referred to as a gas giant, as it lacks a solid surface like the terrestrial planets. Its massive atmosphere is marked by bands of colourful clouds and the famous Great Red Spot, a colossal storm larger than Earth. Much of what we know about Jupiter comes from the space probes Voyager 1 and Voyager 2, launched in 1977. They both conducted flybys of Jupiter and provided valuable data. Jupiter's impressive size is truly astonishing. It has a diameter of approximately 139,822 kilometers, 86,881 miles, making it more than 11 times wider than Earth. Despite its size, Jupiter rotates rapidly, completing one spin on its axis in about 9.9 hours. It orbits the Sun at an average distance of about 778 million kilometers, 483 million miles, taking approximately 11.9 Earth years to complete one orbit. One of Jupiter's most captivating features is its extensive system of moons. It boasts a vast array of natural satellites with over 80 known moons. Some of its largest moons are even larger than the planet Mercury. Jupiter's immense gravitational pull has a significant impact on the entire solar system. It plays a crucial role in shaping the orbits of other celestial bodies and has a protective effect on the inner planets, helping to shield them from potentially hazardous comets and asteroids. Jupiter's unique characteristics and its role as a giant in our solar system make it a captivating subject of scientific study and exploration. It continues to be a target of interest for space missions, with spacecraft like NASA's Juno providing valuable insights into this magnificent gas giant and its mysteries. Saturn, the majestic ringed planet, is one of the most iconic and visually stunning objects in our solar system. Known for its dazzling system of rings, Saturn is a gas giant similar in composition to Jupiter, primarily composed of hydrogen and helium gases. Its rings, composed primarily of ice particles and rocky debris, are a breathtaking sight through telescopes. Saturn is the second largest planet in our solar system, with a diameter of approximately 116,464 kilometers, 72,367 miles. While it is smaller than Jupiter, Saturn is still over 9 times wider than Earth. In terms of its rotation, Saturn is no slouch either. It completes one spin on its axis in about 10.7 hours, making it just slightly slower than Jupiter. Saturn orbits the Sun at an average distance of about 1.4 billion kilometers, 886 million miles. It takes Saturn approximately 29.5 Earth years to complete one orbit. Saturn's rings are not the only captivating aspect of this planet. It also boasts a diverse family of moons with over 80 known natural satellites. One of its moons, Titan, is of particular interest due to its thick atmosphere and methane lakes on the surface. Titan is even larger than the planet Mercury, making it one of the largest moons in the solar system. Saturn's influence extends beyond its stunning appearance. Like Jupiter, it has a significant gravitational pull that shapes the orbits of other celestial bodies. Saturn's gravitational effect on its neighbouring moons, especially those within its ring system, creates intricate patterns and interactions. Saturn's allure extends to space exploration as well. NASA's Cassini spacecraft, which orbited Saturn for over 13 years, provided an unprecedented look at the planet, its rings and its moons. The mission ended with a dramatic plunge into Saturn's atmosphere in 2017, transmitting valuable data until the very end. Overall, Saturn's grandeur, its rings, and its impact on the solar system make it a captivating subject of scientific inquiry and a true wonder of the cosmos. Uranus, often dubbed the sideways planet, stands out in our solar system due to its unique rotation and distinct pale blue colour. This planet is classified as an ice giant. Ice giants are planets made mostly of gases and liquids that are heavier than the gases in planets like Jupiter and Saturn. Uranus is the third largest planet in the solar system, with a diameter of about 50,724 kilometres, 31,518 miles, making it roughly 4 times wider than Earth. One of the most intriguing aspects of Uranus is its axial tilt. Unlike most planets, Uranus rotates on its side, with an axial tilt of approximately 98 degrees. This unusual orientation means that Uranus essentially rolls around its orbit. As a result, each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. This unique rotation contributes to extreme seasonal variations on the planet. Uranus completes a rotation on its axis approximately every 17.2 hours. Despite this relatively fast rotation, a day on Uranus is marked by extreme light and dark periods due to its tilt. In terms of its orbit around the Sun, Uranus is located about 2.9 billion kilometres, 1.8 billion miles away. It takes Uranus about 84 Earth years to complete one orbit around the Sun. Uranus is also home to a complex ring system, although not as prominent as Saturn's. Its rings are composed mainly of large, dark-coloured particles. Discovered in 1977, these rings were the first to be found around a planet other than Saturn. This planet also boasts a significant number of moons, with 27 known. The largest moon of Uranus is Titania. It is the 8th largest moon in the solar system, with a diameter of about 1,578 kilometres, 981 miles. Uranus's exploration has been limited compared to other planets. The most significant mission to date has been NASA's Voyager 2 flyby in 1986, which provided vital information about the planet, its moons, and its ring system. Neptune, the eighth and farthest known planet from the Sun in our solar system, is a captivating world known for its striking blue colour. This coloration is primarily due to the absorption of red light by methane in its atmosphere, along with unknown components that contribute to its deeper blue compared to Uranus. Like Uranus, Neptune is an ice giant. Neptune is the fourth largest planet by diameter and the third largest by mass. It has a diameter of about 49,244 kilometres, 30,598 miles, making it slightly smaller than Uranus, but more massive due to its denser composition. In terms of rotation, Neptune completes one spin on its axis approximately every 16 hours, resulting in a relatively short day compared to Earth. This rapid rotation contributes to some of the most extreme weather patterns observed in our solar system, including incredibly high wind speeds. Neptune is located about 4.5 billion kilometres, 2.8 billion miles, away from the Sun. It takes this distant planet about 164.8 Earth years to complete one orbit, making its year exceptionally long by Earth standards. Neptune's moon system is dominated by its largest moon, Triton, with a diameter of about 2,710 kilometres, 1,680 miles, making it the seventh largest moon in the solar system. Neptune also has a faint and fragmented ring system discovered in the mid-1980s. These rings are made up of dust particles thought to be the result of micrometeorite impacts on Neptune's moons, which then spread into orbit around the planet. The exploration of Neptune has been limited, with the most significant information coming from NASA's Voyager 2 spacecraft, which flew by the planet in 1989. This flyby provided invaluable data on Neptune's atmosphere, moons, and rings. Okay, now it's time to head home to the third planet from the Sun, Earth. Earth stands out in the solar system as the only known planet to support life, a trait attributed to its unique combination of atmosphere, water, and distance from the Sun. It's the fifth largest planet, with a diameter of about 12,742 kilometres, 7,918 miles. Earth's atmosphere, primarily composed of nitrogen and oxygen, plays a crucial role in sustaining life. It provides breathable air, protects life from harmful solar radiation, and helps regulate the planet's temperature through the greenhouse effect. This effect, much milder than on planets like Venus, is crucial for maintaining a habitable climate. One of Earth's most distinguishing features is its abundant water, covering about 71% of its surface. This water exists in various states, liquid in oceans, rivers and lakes, solid in ice caps and glaciers, and gaseous in the atmosphere. Earth's hydrosphere is vital for all forms of life and influences various climatic patterns. In terms of rotation, Earth completes a spin on its axis every 24 hours, leading to a regular cycle of day and night. This rotation, combined with its orbit around the Sun, results in the seasonal variations experienced on the planet. Earth takes about 365.25 days to complete one orbit around the Sun, defining our year. Earth's surface is dynamic and constantly changing due to tectonic activity. This activity shapes continents, causes earthquakes, and leads to volcanic eruptions. The planet's interior consists of a solid inner core, a liquid outer core generating the magnetic field, a viscous mantle, and a solid crust. Earth has one natural satellite, the Moon, which has a profound effect on the planet, including its tides and some aspects of the climate. The gravitational pull between Earth and the Moon also stabilizes Earth's axial tilt, which is important for the seasonal cycle. Human exploration of Earth is extensive, yet the planet still holds many mysteries, especially in its deep oceans and the complexities of its ecosystems. Earth's position in the solar system and its life-sustaining qualities continue to make it a subject of scientific inquiry and wonder.
Don't forget to subscribe.